Okay, well, we'll start the concept compressible flow. Compressible flow is also known as a variable density flow. Consider a fluid element of volume V. If the pressure is exerted on the element by the neighboring fluid is P, then there is a change in the pressure of that element, that is dou P or dP. The volume of the element will correspondingly reduced by the amount dV. Therefore, the compressibility can be defined as it is a minus 1 by V dou V by dou P. Here the negative sign indicates there is a reduction in volume. Therefore, similarly, the temperature of the gas would increases when compressed. Considering the isothermal conditions, isothermal compressibility is defined as K, compressibility of isothermal condition, is equal to minus 1 by V dou V by dou P with respect to T, that is temperature, constant temperature. For example, if we consider a fluid motion, that flows are initiated and maintained by changes in pressure on the fluid. It is also known that the high pressure gradient is responsible for high speed flow. However, for the given pressure gradient, the change in density of liquid will be smaller than the change in density of the gas. So for flow of gases, high pressure gradients leads to substantial changes in density. Due to such pressure gradient, gas flows with high velocity. For such flows, the density is variable, therefore it is known as compressible flow or variable density flow. The next heading is Mach number. The flow patterns can be identified with the help of this Mach number. It is the most important parameter in compressible flow analysis. It is given by, or it is defined as, it is a ratio of V by A or V by C. It means it is a ratio of velocity divided by sonic speed. For incompressible flow, this Mach number is less than 1. If Mach number is less than 0.3, that is called as incompressible flow. For that we need to neglect the density. If Mach number is in between 0.3 and 0.8, the type of the flow is called as subsonic flow. In this type of flow, density changes are significant, but shock waves do not appear. If Mach number is in between 0.8 to 1.2, then the type of the flow is called as transonic flow. The shock waves appears and divide the subsonic and supersonic regions of flow. Similarly, when the Mach number is in between 1.2 and 3, this type of the flow is called as supersonic flow. During the supersonic flow, the flow field is everywhere above the acoustic speed. Shock waves appears and streamlines direction changes discontinuously. See, this is supersonic flow. Definitely there is a separation of streamline. Streamline means the fluid particle moves along a straight line. The first layer is parallel to the second layer of the fluid particles, but due to the supersonic flow there is a disturbance, therefore the streamline direction changes. If the Mach number is less than 3, then that type of the flow is called as hypersonic flow, where the temperature, pressure, density of flow increases explosively across the shock waves. Okay, the next heading is thermodynamic relations of perfect gases. Perfect gas is the one in which there is no intermolecular force. The complete intermolecular force are neglected. The equation of the perfect gas state can be derived from the kinetic theory. The compressible flow calculations are made by assuming the fluid is perfect gas. Therefore, we know that for the perfect gas, PV is equal to mRT, where P is the pressure, V is the volume, M is the mass of the system, R is specific gas constant, T is the temperature. The equation of the state can be written as PV is equal to RT, or we know that from the density is equal to mass per unit volume, therefore P is equal to m by v. That m by v is nothing but density, therefore P is equal to rho r T, where rho is density of gas in kg per meter cube.